This is a walkthrough of problem 3 on exam 2 of module 10 in the book Problem Solving Guide for Electromagnetism and Optics. A fish is 7 feet deep in a horizontal distance of 4 feet away from the bank of a lake. The water is clear, has an index of refraction of 1.33. A 6-foot person is walking toward the bank. How close to the bank can the person be without the fish seeing the top of his head? So light from the top of the person will be visible to the fish as soon as the light coming from the person's head has a path to the fish's eye. Let's add a 6-foot person and then the path of light. It's going to bend when it hits the water. So light's coming off the person's head, hits the water, bends towards the normal, down to the fish. The fish has no straight line of sight to the person's head, but the light will bend. Let's put in the normal at the interface. And now we can use these two distances, given distances, the 4 and the 7, to calculate the angle in the water. Let's put an angle in here. Let's call it alpha right here. Tangent of alpha is 7 feet over 4 feet. And we can calculate this angle as 60.26 degrees. We don't want that angle, we want this angle, the angle from the normal, but it's easy to get. We'll just subtract 60.26 from 90. And we get 29.74. So the direction of the beam in the water from the normal is 29.74 degrees. Now we can get the direction in the air because we know the indices of refraction. Using Snell's law, keeping track at the index of refraction in the water, the angle in the water, index of refraction in the air, the angle in the air, it's 41.29 degrees from the normal. Let's put it in. 41.3 degrees from the normal. We know the angle from the ground is 90 minus that, which is 48.7. So now we have this angle, and we know how tall the person is. So we can calculate the distance from the bank. Tangent of 48.7 degrees is the opposite side, which is 6 feet, divided by the adjacent side, which is the distance from the bank. Punching the numbers in the calculator, we get 5.27 feet for the answer. And that's problem 3.